Good morning, students. Welcome to class 11th. I know you all must be excited. Today is the first day of your class 11th. So you all must be excited to learn new things. So you are welcome to the new session and to the new class. So I'll be teaching mathematics to you. You all are aware of that. So the very first chapter we will be discussing in this session is sets. It is part of Unit 1. Unit 1 contains 3 chapters. One is sets, then next one is relations and functions, and then the third one is trigonometric function. Okay, so the first unit is consisting of three chapters. Okay, so the first one we will go through is sets. Okay, so firstly I'll tell you some important terms related to it, then we can apply those to the questions. Moreover, till now you are aware of the largest set of numbers till 10th which we have discussed. It is real numbers, and you are aware of the general notations used for these numbers. We'll quickly go through them first and then we will talk about the sets. Okay, sets, firstly you know what set is, then we will see whether those numbers you have gone through can be a type of set or not. Okay, so you will take down the definition of a set. We can say, see, as the term suggests, if you just think, you will quickly get an idea. A set can be collection of something, but not randomly collecting anything. When we make a collection, we see there is something common among those objects. So when you are writing a selection, we will try all the elements or whatever term is included in that set, they all share something common with each other. So keeping that in mind, a set can be defined as, it is a collection of we can say well-defined objects. Fine. So set can be defined as a collection of well-defined objects. Okay. Now let us try to apply it to what all we have learned till now. The largest category of numbers we have learned is sets, real numbers. So real numbers, how do we denote? The notation we use for real numbers is R. Understood? So R is denoting what? It is collection of real numbers. So we are defining what R is denoting, what kind of collection. So R is a set. Okay. In the same way, then if we talk about rational numbers, rational numbers are denoted using the notation Q. Fine. Integers can be defined using the notation Z. See, Q is also a set. It is denoting a particular type of, see, Q becomes a particular case of R. R is general set. It contains all the real numbers. But Q is containing only those real numbers which are rational numbers. So this set is not containing irrational numbers. Coming to integers, then again, integer is again a particular or special case of Q or R. We can say Z will contain only integers which will be counting numbers 1, 2, 3, 4. It will include 0 also, and negative of counting numbers. Okay, whole numbers we can denote by using W. Then natural numbers we have gone through. Natural numbers can be denoted by N. So these are some examples of sets. We have knowingly or unknowingly, we have already learnt about them. These are special collections. Okay. If I talk you about alphabets in English, that is also a collection. We are very well defining what is this collection all about. Okay. So these are some examples of well-defined collections. Then there are some of the notations which you will go through every now and then. I will be using. You can write down those symbols. This is the symbol for there exists. Then another symbol, this one, this denotes for all, or you can say for every. Fine. So these are just the notations. These are the example of sets. Now, once we know what a set is, we need to know how to actually write a set. You will find how it has to be represented. So the next thing we will discuss is representation of sets. Now, there are two types of representations. One thing is, look at this one. If I only write the notation Z, everything is understood to us. We know it is collection of integers. But we can think of writing using some other method also. If I list the integers, okay, instead of taking integers, let us go for natural numbers, because we can define the smallest natural number. That we cannot do with integers. Okay, if I talk about natural numbers, this is an easier case to understand. Either I simply write n and we get an idea we are talking about natural numbers, or I simply list the numbers as 1, 2, 3, 4 and so on. So that also gives us an idea quickly that we are talking about the natural numbers. So I have just now talked about two ways of defining natural numbers. Either I simply write n, or I start listing the numbers I am talking about. 1, 2, 3, 4, 5 and so on. So these are two ways of representing the set of natural numbers. So keeping that in mind only, we will define the two methods in which the sets can be represented. The first one is roster form. This is the name of the form. It is also called tabular form. So roster form or tabular form. Let us see what this form talks about. In this form, if I am writing a set using roster form, then the elements are to be listed. Elements are to be listed means we are going to list all the way I took the example of natural numbers. So if I have to list the natural numbers, I will write them as 1, 2, 3, 4 and so on. Now, you will write for roster form, then we'll take one example. In roster form, elements of set are listed separated with comma within the braces these. Okay, so if I am writing the objects of the set or elements of the set in roster form, then I am going to list them. And when you are listing them, each element will be separated with a comma and they will be written within these two braces. This bracket is the only notation for set. Okay, see, when I have written set as it is a collection of well-defined objects, whenever the listing is done, if you see, this is also a set, but I have not used braces, those brackets, because I am not listing them. So if I am listing the elements in the roster form, we have to put these braces, and within these braces, you will list the numbers or elements or objects you are talking about, and every two objects will be separated by a comma. Let us take an example of this. Okay, for example, if I say vowels, vowels from English alphabets. Okay, so if I have to write it in roster form. I will write it as in this form. Okay, so you can see all the 5 vowels are listed. They are separated with comma and they are written within the braces. Okay, you can see here the elements can be counted. 5. I'll take one more example. Say I have to write natural numbers. Set of natural numbers. Okay. Set of natural numbers. So again I have to list the numbers. We know the smallest natural number is 1. So I can write it as 1, 2, 3, 4 and so on. We cannot tell what will be the largest natural number. So we need to put dots. What is the difference you find in these two? Here the number of objects we were able to count, they were finite. Here the number of objects are infinite. So both the cases are possible. Okay. Then the second form is set builder form or property form. See the second name, that will quickly give you an idea what this form is about. When I say property form, that means we are writing the set by defining the properties of those elements. As I told you initially, when we write the objects within a set, they must be sharing some common property. So we can define the objects of the set using their property also. Not every time it is necessary to list them. So this can be another form which can be used to define the elements of the set. So writing for the set builder form, you will write in this form, we can say elements of the set, elements or let me say objects of the set are defined through their property. Okay, let us take some example for this also. Let us assume example, let us say again, if I say set of natural numbers. Can be N. So simply I can write capital N because I know there is a notation for the set of natural numbers. I don't have to list it. If I simply write capital N, we know we are talking about the set of natural numbers. Okay, let us go for another example. Suppose given set is let me say in roster form, a set is given to us where the elements are written like this. 2, then 4, then I have got 8, then I have got 16 and so on. Now look at these elements. Okay, this is okay. Let us make the set finite. 32. You can see there are 5 elements and they share a common property. You can see these are all exponents of 2. Okay, in which form? This is 2 to the power 1. This is 2 raised to the power 2. This is 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5. So each element can be written in the form of an expression where base will be 2 and the exponent keeps on changing. Okay, but we know the smallest value of exponent is 1. The largest value of exponent is 5. So in set builder form, we can write it as it is, see how I write? I can write the elements as x. Okay, so I am saying every element of this set is denoted by the variable x. But what is the nature of x? What is the property of x? So we can define where x is equal to 2 to the power n. X is of the form 2 raised to the power n. Like for the first value of x, it is 2 raised to the power 1. For second value, it is 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5. So we know the value of n keeps on changing. So we need to tell what n is. N is a number which is greater than equal to 1, less than equal to 5. So the smallest value of n is 1, the largest value of n is 5. Now you may think that there are rational and irrational numbers also between 1 and 5. So is n that also? No. N is only the natural numbers. So we need to define what n is. N belongs to capital N. So this is the notation for belongs to. Initially I have given you two notations for there exist and for every. You can include this also there. This symbol. This denotes belongs to. So you can see this is set builder form of the same set. We are defining the property of the element and then the set is being defined. So these are two representations of in which the sets can be represented.